जिसने भी हमारे चैनल को अभी तक लाइक नहीं किया वो लाइक कर दीजिए, चैनल को सब्सक्राइब कर दें और बेल आइकन को प्रेस कर दें, जिससे हमारे आने वाले वीडियो का नोटिफिकेशन आप तक पहुंच सके। गुड मॉर्निंग स्टूडेंट्स, दिस इज लेक्चर नंबर 4. In this lecture we solve assignment number 4 problems. Now see question number 1 in assignment number 4. The question says a brake applied to a drum by a lever AB which is pivoted at point A as shown in figure. The radius of drum is 175. The coefficient of friction is 0.3. If the drum rotates clockwise, find braking torque if force of 500 Newton at point B. Now we noted out given data in question number 1 here. Radius of drum is 175 mm. Coefficient of friction 0.3. Drum rotate at clockwise direction. Applied force 500 Newton at point B. At a given figure, theta gives 25 degrees. So 2 theta is 50 degree. This is less than 60 degrees. So this is not case of pivoted block brake. Okay. Now see in a figure, this is given figure. Here this is the axis of rotation of wheel or center of rotation of wheel. Here A is the fulcrum point. The distance 215 is between A and line of center of rotation of wheel. So the radius of wheel is 175 mm. Now see in this figure. Here please see in this circle. Here 215 is this and R is smaller as 215 mm. So here is a distance between point A and direction of motion of tangential force, this. So we has assumed this distance as small a. Now wheel rotates in clockwise direction, so Ft is act in rightward direction, Ft, and A is 215 minus R. So A small a is equal to 215 minus R. R as 175. So A is 50 mm. So the distance between point A and line of action of tangential force Ft is 50 mm. So first take a moment about point A. P into L. L is the sum of 325 and 375, that is equal to 700 mm. So P into 700 mm, it's make a clockwise couple about point A. Now noted here. we assume clockwise couple in positive sense and anti-clockwise couple as negative sense. So P into 700 Newton. Next, Rn into 325. It's make anti-clockwise, so it having negative sense. Rn into 325. Next type couple is Ft, tangential braking force, into A. It's make a anti-clockwise couple about 0.0, so it has also negative sense. So it makes equation like this: P into 325 plus 375 minus Ft into A minus Rn into 325 equal to 0. It simplifies as putting the value of P and A in this equation. So we generates a equation as 500 into 700 minus Ft into 40. 40 is calculated as this: A is equal to 215 minus R. R is 175, so A is 40 mm. Now putting the value of Rn in terms of Ft and mu. So we calculated Rn from here. So we write a simply form of the equation as 500 into 700 minus Ft into 40 minus Ft upon mu into 325 equal to 0. So it also simplifies as 35 into 10 to the power 4 minus Ft into 40 minus Ft into 0.3 into 325. It is also simplified as 35 into 10 to the power 4 minus Ft into 40 minus 1083.33 Ft equal to 0. Now from this equation we find Ft. Ft is tangential braking force. Ft is calculated as 311.57 Newton. In this question we find braking torque. So we can calculate braking torque. Tb is equal to Ft into R. We also know Tb equal to 311.57 Newton and radius as 175 mm. So Tb is equal to 524.75 Newton mm as tangential braking torque 54.52 Newton meter. So first question is solved. Now move on second question. This question is very tricky, but it is very simple. Now read question carefully. The block brake is shown in figure provides a braking torque 360 Newton meter. So firstly it gives braking torque 360 Newton meter. The diameter of drum is 300 mm. So diameter of 300 mm and radius is 150 mm. The coefficient of friction mu is 0.3. The coefficient of friction 0.3. Now find first the force P to be applied at a free end of the lever when drum rotates clockwise and anti-clockwise. In this question we find applied pressure force when wheel rotates clockwise or anti-clockwise. Now we calculate applied force P when wheel rotate in clockwise direction. So please see in a figure, this is very important. Here the center line of rotation of wheel here, and this is the point A, pivoted point of fulcrum. The distance between these two lines is 100 mm. So this is 100 mm and the radius of wheel is 150 mm. So there is a gap between point A and line of action of tangential braking force. So please see in a figure this. Now zoom on. This is the central line of rotation of wheel. This is the pivoted point A. This is the gap between 100 mm and this is the radius R. So there is a difference as A. So we can calculate A as 150 mm radius and 100 mm is the distance between point A and central line of rotation of wheel. So A is equal to 50 mm. Now see in solution. There A is 50 mm. Now taking moment about point A. Sorry, here is noted out O. So he is A. Not O, it is A. So when wheel rotate clockwise direction, so Ft is act towards right. So P into 600 plus 200, it's make a clockwise couple about point A. So putting the values in this equation, P into 600. Now Rn into 200, it's make an anti-clockwise couple that make in negative sense. Now Ft is here and it is above at point A, so it makes a clockwise couple. So Ft into A, it's make a positive sense equal to 0. So first we find out the applied pressure force when wheel rotates in clockwise direction. Now we know the braking torque is 360 Newton meter. So braking torque is Ft into R. We also know R is equal to 150 mm and T is equal to 360 Newton meter. So here we calculate Ft by using these relationship, and Ft calculated as 2400 Newton. 2400 Newton, and we also find the value of Rn by using this relationship. We know Ft is equal to mu Rn. We have value of mu as 0.3. We have also value of Ft as 2400 Newton. So we can easily find out the value of Rn as 8000 Newton. So we have find out Ft and Rn. So now we take a Okay. We have developed a momentum equation as this: P into 200 plus 600 plus Ft into A minus Rn into 200 equal to 0. Now putting the value of Ft and Rn in this equation, in momentum equation. So we can calculate it P. P calculated as 1850 Newton. This. Please checks all calculations yourself, and this is the exact value of P is equal to 1850 Newton when wheel rotates in clockwise direction. Now move on, wheel rotates at anti-clockwise direction. Only one difference is Ft is tends to left when wheel to anti-clockwise direction, and when wheel rotates clockwise direction, Ft will tends to acts towards right side. So develop equation of moment: P into 200 plus 600 minus R into 200 minus Ft into A. Minus Ft because Ft in left side direction, and this is the A, and its acts a anti-clockwise couple. So we assume anti-clockwise couple at negative sense. So we develop the equation as P into 200 plus 600 minus Rn into 200 minus Ft into A equal to 0. Now we put value of Ft and value of Rn in this equation, and we get the value of P. So we get value of P as 2150 Newton. This is the exact value of P when wheel rotates in anti-clockwise direction. Okay. Now we find second determination as the location of pivot of fulcrum to make the brake self-locking for the clockwise rotation of drum. In the determination, we find out the location of pivot or fulcrum to make the brake self-locking. We also know the condition of self-locking. In self-locking condition, the applied pressure force is 0 or maybe negative. So in this case, we assume P is equal to 0. Now move on this condition here. Second point, self-lock condition in clockwise direction. Let assume B is the location of pivot from Ft. So we assumed here small a. In determination of second case, location of fulcrum, we assume B in similar conditions, but here Ft is left hand side because wheel rotates anti-clockwise direction. Now see in this figure, this. In this figure, wheel rotates clockwise direction, Ft is towards right side. So here small a used. Now determination in second case, we use small b as substitute of small a. Okay. Now move on second determination. This we can develop a momentum equation as P into 200 plus 600, P into 200 plus 600 minus Rn into 200 because Rn develops anti-clockwise couple minus Rn into 200 minus, sorry, it sends positive Ft into B. It's make a clockwise couple, so Ft will positive sense here. Okay, so we get a momentum equation as P into 200 plus 600 minus Rn into 200 plus Ft into B. In self-locking condition, we discuss as P is equal to 0. No applied pressure force is required to develop braking. So P is equal to 0. P is equal to 0, putting in this equation, we get 200 Rn equal to Ft into B. Putting the value of Ft as 2400 Newton in this equation and value of Rn in this equation, we get find the value of B. Okay, I am again repeat the value of Ft as 2400 Newton and the value of Rn is 8000 Newton. Put these values in this equation and find the value of B. B as 666.67 mm. This is the location of pivot of fulcrum to make the brake self-locking. Okay.